Let's wait for five more, like you can say 3 to 4 minutes more. If Shivay not able to join, then we can start off. Cool. I guess maybe Shiva will join us a bit late, maybe, but I guess we can start off. Thanks, folks, for joining for today's session. Like, it's not a session; it's like more like a chit chat kind of thing. We called it here Tensor Talks, basically, where we have just a brainstorming thing around ML. And audience, if you have any doubt regarding ML careers, how to get started off with, or if you have related to question, any related to question around machine learning, obviously you can raise your hand if you want to directly talk with it, or otherwise you can drop down in the chat if you have any query, any doubts around it. And nothing much more time of mine, but let's start off with our speakers. So I will go last, but I guess can start with Karan. Karan, can you give a basic introduction to everyone else? Yeah.
Yeah, sure. So, hello everyone, and I am Karan, and I work as a data scientist and also solutions architect with the various enterprises. My major workflow involves enabling enterprises to integrate data science solutions. So, some of the use cases you might have heard are RAG, graph-based RAG. Like right now, QA and chatbot side of applications is also something that I have to do majorly. But besides that, a lot of data science algorithms go into manufacturing and spaces. So I am the person that usually gets to research and develop. So glad to be here and happy to answer any of your questions.
Cool. Thanks, Karan. I guess I can go next to Abheesth. Abheesth, can you share your introduction, bro? Yeah.
Hello guys. I'm Abheesth and I'm an applied scientist at Amazon. I work in the Amazon ads team, in particular the traffic quality team, and our task is basically to devise machine learning solutions for catching advertisement bots. The Amazon website has a lot of sponsored ads, and our task is to catch those bots. Uh, and so other than my normal work, I contribute significantly to open source, and I was involved with developing Keras NLP, which is like this new library which was built by the Keras team uh, for NLP use cases and workflows. Yep, that's pretty much it.
Thanks, Abheesth, for your introduction. And folks, if you have any queries around anything regarding ML or ML career, please drop down in the chat. And if you want to talk to directly 101, you can raise your hand and you can directly talk to the speakers. But let's get to the very start or basic. Karan, just my question to you: how you start off with your ML career? How's your journey? How you get into it, and how you involve with the communities? Can you share your journey basically in precise, if I will say? Yeah.
Sure, sure. So my journey started off when I was doing engineering, and my faculties were like some of the teachers that I was close to. They were working on some data science problem sets, specifically genome sequencing. And I was already like a Marvel fan, and everybody was must have heard of Jarvis. Right. So by that time, I was like, I'm really ready to start working on this. And
foundational algorithms for professional networking. And I worked there for about 1 year before I graduated in 2020 and was part of the founding team. I was a founding engineer at the startup called Dark Horse, where we were building a computer vision based AI platform, which will use object detection, object tracking algorithms to detect athletes inside of videos of soccer matches. And we are trying to make a prediction of what kind of actions are they scoring. So it was a really AI heavy experience, and I worked there for about 2.5 years, working primarily on the entire machine learning pipeline. So the deployment and also some of the basic AI models. So that was a really good experience to just focus completely into a AI specific product, and I got to work closely with professors from Stanford and CMU who helped us with evaluation of our models, because of course we had to build all these models from scratch. And as you can imagine that it is not just like one single AI model that we were using for object detection. There were multiple models that we were using. So object detection, object tracking just for tracking the actual athletes, then separate algorithm to train for tracking the ball, a separate algorithm to detect what kind of jersey number the players are wearing, the jersey color would be a separate model. And then the idea was that we were using a camera stream, which is basically like, we can think of it as like a 3D, right? But then you would, using homography, you would convert it into a 2D plane and visualize the players as dots on those 2D planes. So doing that uh, conversion of that 3D video into a 2D flat plane, and then also like detecting the edges of the fields. So I mean, we had this entire massive AI pipeline, and then learning how to make it even basically deploying this on top of Kubernetes with GPU support. So a lot of my experience there was getting into MLOps as well. And around 2020, I also started to contribute to the TensorFlow JS project with the WebAssembly backend. And ever since I've been contributing fairly regularly, both in terms of the community aspect and then also teaching people about that same project. Both me and Kartikey have been involved with that. So that's in a nutshell what my experience has been. Right now, I'm working a lot of the Gen AI applications at Couchbase. It's a NoSQL database platform where we also introduce vector search. So just off recently, like I've started to dive deeper into Gen AI, and like with all of the amazing stuff that's happening in the Google ML space, and all of the great collaborations that we're having with Kiraz. I've just recently started to dive deeper into Palijama and with Kiraz and LP. So that's in a nutshell what my experience is.
Cool. Thanks, Shivay. Obviously, like I and Shivay worked with TensorFlow.js during that time. We were on that time. I guess we gave a lot of talk around TensorFlow.js intensely. So yeah. The next question to maybe everyone, like generally what beginners ask actually, machine learning is very hard. How they can start off and why they are not get into the FOMO thing. Like everyone is doing better than us and we didn't know anything. So maybe Karan, can you start off like what's your point around it? Like maximum beginners come to me and they will say we not very have a strong machine maths foundation also, and everyone is doing far more better than us, and how we can get into the competition in that sense. So what's your take on that, Karan? Yeah.
Um, to be honest, even when I started, I was like, yeah, this is such a vast field. It still feels like that. And um, like the thing that I would say to anyone starting with it is that you just need to like start with like basic ML algorithms that would be like just understanding regression, understanding classification, very simplistic supervised ML models, and from there you just start get some intuition around things. Then you see like right now since LLMs are quite popular, so everybody is like going directly towards deep learning based neural networks. So I feel that if you do that, there is a big chance that it will give you even more of a scare that it's pretty complex when you need to understand embeddings, when you need to understand how vector databases work, and like basically how the model was trained. Like you are directly examining a 500 billion parameter or a 100 billion parameter model, which you should have started with like a very simplistic regression model to give you some intuition of how things work. So that is something that I feel people who are trying to start in like learning at least in ML and DL space, they should do like just have a little go with simpler algorithms to get some intuition. Play with them, play with linear regression, add more variables to it, and see how you can plot that line, how it's able to classify. Like if you once you have that thing, once you have practice some stuff with it, um, you will see like now you don't fear the uh, like the vastness of the field exactly. Like you are like excited. Okay, I understand how this works. Now I can explore more, dive deeper. Second is you don't need to learn everything. So I'm sure everybody who has been working in this field, they know like there are specific problem statements that need specific solutions. So you need to know a little bit about other stuff. You need to know basics, but you don't need to know everything in advance. Like Shiva talked about converting computer vision based projects. So he specifically learned in that domain. He did not explore NLP and revision simultaneously very deeply and say, okay, like I am, I know all of the stuff. He will explore as he needs. His basics are strong. That's what enables him to do that. So that's one thing that I will tell anyone who is starting to at least to learn. And if you have a project that you have been told to do, then that's a different story. Then you just need to basically flip something up, make a hackable solution, and like yeah, start with that, to be honest. Um, just make it work, I will say, rather than trying to understand it. Because if you do, there are like every topic has 10 prerequisites that you also need to be clear of. In terms of math, I won't say it's like uh, like you require it as much as people think or as much as people are scared of. You just need to understand some basic algebra and like slowly when you move towards more complex models and some little bit of calculus. But at the end, everything is being done by autograde and like all the already implemented solutions. So I will say just understanding is more than enough if you are trying to implement some solutions here and then move forward and research more in your specific use case that you have input to build.
Thanks, Karan. I will ask your question, Nishan, at the end of this question. But I same question to Abheesth. What your thoughts on that, Abheesth? Like what maybe you can say tips you can give to folks who wanted to get started, but they are getting kind of FOMO or have a strong behold around mathematics around it. What's your take on that? Yeah.
Yeah, so first of all, do not be scared of the subject, right? That is the most important thing. It's not that hard. Uh, and the best thing about ML is that because so many people are working on it, there are a gazillion resources out there. It is not something like a systems thing where you really need to, uh, you know, uh, try to find resources to learn or read whole textbooks to learn stuff. ML there are blogs, there are discussion threads. Um, there are so many resources you can tap into. There are so many MOOCs. So how I would suggest is j- just do a basic, like if you're still an undergrad or you're still studying, then one option is to uh, do any MOOC or sign up for the ML course in your university or college. So that way you get the basics right. And then the best thing to do is to you can um, is not your ordinary school course, or uh, do rote learning for 4 months, get good grades, and forget about it. You have to be hands-on. You have to. It's an applied science, right? So you have to be hands-on. And so one way I learned is I used to pour over code. For me, at least, reading code. So code is like the single source of truth. So I mean, you can read papers also, but like in papers, I've seen that uh, things are sometimes explained in a very fancy way, and then when you distill it down into code, it's a very simple thing. So how I did it is I started off with a basic course. I had an ML course in my university. I did that. I did some MOOCs. And Stanford courses are great. There's CS231N, which is great. So you can take your pick. You don't need to do all of them. You can just take your pick. Get a general idea of the field. So there are two things here. There's breadth and there's depth. So initially, when you start out, you should focus on breadth. Uh, like having a general overview of things. For example, having a general overview of what a transformer is, or what a CNN is, or what a normal multi-layer perceptron is. So first, you should focus on breadth, and then you should focus on depth. So depth is when you pick one particular subfield, uh, or one particular problem statement, and you drill down. You try to you know learn as much as you can about it. And and this is, of course, coming from a research point of view. If you guys are interested in research, then this is how you should proceed. But again, like there are different layers of abstraction here. So, like, for example, uh, because of LLMs and chat GPT and so on, uh, many things have just become an API call, right? uh, and many startups are doing that. So in that case, you maybe need to focus more on the software side of things and less on actual ML. You know, but then if you're building your own models and so on, then you need to dive deeper. Um, so yeah, I mean, in terms of math, uh, I think there are three things which are needed. There's calculus, there's probability and statistics, and there's linear algebra. So linear algebra and probability statistics are actually a part of your, I mean, at least for me, it was part of my first year curriculum. And that is sufficient, and even calculus, of course. So calculus starts in +1, +2, and then first year they go deep. So like these three courses are all you need. And they are a part, like if you're in an engineering college, then they are necessarily a part of your curriculum, irrespective of which branch. Um, uh, so if they're not a part of your curriculum, then again, you can, as I said, like there are so many resources out there. So um, uh, the ML MOOC which you are probably watching or studying might have some basic math to start off with. Then, for example, linear algebra, you can watch this lecture series by Gilbert Strang, which is, of course, very much detailed, and you don't need to go into that much detail if you're not looking to do a lot of theoretical research and so on. But the thing is, there are resources, and there are people in the community you can reach out for help, who are always, willing to give you suggestions. So, as I said before, like never do never study solo. Tap into the community. Maybe find a bunch of people who are also interested, and study with them or discuss things with them, and that will make your learning journey faster and more enjoyable as well. So that's how I did it. And yeah, I think that's pretty much my take on it.
Yeah, thank you, Abheesth, for that. We have a question. What your thought process is there? Like you have a different perspective to add on to that. Yeah.
No, I think both Abheesth and Karan, they put it out so meticulously that I don't really have anything to add to what what they already mentioned. But I think yeah, this is the point that the last point that was mentioned was uh, being part of these study groups, because I completely understand that is a similar case for me, that yes, we have studied math and we have studied the calculus courses back in plus one, plus two, and all in our first year of university. But now you're implementing it in a different way. It's not just about, hey, that I've given you a question on solving this equation, calculus equation, and just solve it, right? You're now applying it to a real world use case where you're trying to solve this algorithm. So if that is the case where you're struggling, and again, like for me it was that maths never came easily to me. Like for me, I had to study the same algorithm, 3, 4, 5 times before it actually set to me and I was able to understand. Like for example, especially when it came to like coordinate geometry. Now of course coordinate geometry is a bit separate, but you can still apply logic such as so one of the projects that I focused on during 2021 was working with MediaPipe in Unity. And there we were building, for Google Summer of Code, we were basically building the capability of having like a VTuber, which is basically a avatar, a 3D avatar that uses the MediaPipe holistic model, and it can see the key points of your joints moving, and it has key points mapped across your entire body, including the 400 and I think 400 odd facial landmarks. So, for instance, if you now want to see that, okay, is a person opening their mouth? Now, the shape of your lips can actually create an ellipse. So we had to go back and study the mathematical properties of an ellipse, which is part of coordinate geometry. And I absolutely hated coordinate geometry back in 12th. When I was preparing for IIT, we had concepts like I think hyperparabola, parabola, all those. I was never too good at those. Like even after like studying them for 5, 6 times, but now since I had this clear vision that okay, I have to apply it and solve that, I want to see the lip movements, how large has someone opened their mouth, because that would cause the VTuber to show, okay, like if you're trying to speak, it is also using that. So we use those application that, okay, like when you increase the size of an ellipse, what is the, I think like it's like A into B equal to some, I forgot the formula, I'll have to revise it probably again. But the point is that when you apply these real world concepts, you can really understand them. And that did involve me to be in a group study with the other mentors in the Gold Stone of Code program and the mentee who was actually building this. And we collaboratively we studied about ellipse together, documented it, and then we came up with the actual algorithm. So I think these kind of things, and especially like with machine learning, it's great that if you can be part of these ML boot camps. In fact, like TFUG, Durg, and a bunch of other Tensor user groups are also conducting monthly boot camps. So definitely be part of those if you are just getting started. At least with Tensor user group, with the Durg chapter, we have already had multiple sessions on linear regression and basic of math. Kartikey himself has taken up that one. So if when you are part of this continuous cycle, like you can collaborate globally. There are also other people who are attending, other folks who are attending these sessions, so you can collaborate with them and learn from each other. So yeah.
Yeah, thanks, Shivay. And I guess thanks for the great tips. I hope so. Everyone got your point. Like that's the major thing that makes some people asking. Ishan, let me start with the Q&A for now. Ishan, I have a question to Karan, I guess. My question is to Karan, sir. My branch is data science and have started with Python as a base for my programming language. What are the things that I need to learn for turning my Python journey to AI/ML? And like, what are the topics like I need to cover up?
So that's really awesome, actually, that you have Python already in your learning path. And if you are familiar with Python, so I would like to know. Like no more like if you are working towards Flask or fast GPA sort of backend development, or moving towards using libraries like PyTorch or TensorFlow in terms of ML development. So I will recommend that doing both of these. Like basically you should have some experience making just very simple applications with Flask or fast GPA, like just very simple backend apps that just serves a model. Besides that, you can then work on a library focused docs. So like you can explore TensorFlow, let's suppose. So TensorFlow has a lot of documentation, a lot of blogs tutorials that you can use to implement specific use cases, and that would give you more confidence. Okay, this is how this model has been done. What you can do next is basically combine your fast API or like that API with that model so that you can serve the model response somehow, and that would give you much more confidence building software as a data scientist, and showcasing that also. Other than that, you can use Dash, Plotly, Streamlit, and Google's also released a new visualization package. I am not remembering the name right now, but it's also something you can look at. So basically, these visualization packages like Dash and Streamlit, they allow you to showcase your ML models to other people. Like it's much easier for them to, okay, like this is what your model do. If you input text, it will output text, it will output image. If you upload this particular image, it will do this. If you upload a video, it will do this, something like that basically. So these specific frameworks are very important in showcasing that journey. Anything Gradle or any bouquet and anything of the visualization framework that can basically showcase the model capabilities is very important. So I will say that if you can focus on these two three things initially, after that what you can do is you already heard about the basic ML algorithms, and I think you will learn that in your curriculum as well. um, but besides that, while you are going to play with them and that is done, you can pick specific use cases and start building some sort of solution there. Basically, if you have one or two strong use case based solutions implemented that you can show to your where you apply for internships or for jobs, so it will really present a very strong case in front of your interviewers, and gives them the confidence that yeah, this guy really knows his stuff. Other than that, if you want, you can definitely, if you feel like you are confident with Python, and if you do all this stuff, you will be like knowing how software like how they are like architecting software, how they are architecting code bases. So it might help you with contributing to open source projects, and that would be a great achievement as well, so that you can that will help you grab more opportunities in future.
Thanks, Karan. Next question is from Chick Ice Cream. Sorry if I'm like I don't know your name. So hello, I have been working on AIML for some time now. I started kind of covering the basic algorithm to understand the maths behind them. Then I worked on making basic neural network, then understanding that from the maths too. Now I'm trying out generative AI and making apps using LLMs. I have also worked with OpenCV projects. I want to know if am I moving too fast. I want to get an internship in this field to learn more, and how do I grab that? Is there anyone who want to take it, because it's like a very general question?
I think I can probably just add my 2 cents to this. So, pretty much bouncing off the idea that was
So
discussed
maybe
in this
this
panel
question.
just a few minutes back. Hello, can you hear me?
Yeah, we can hear you.
Hey, Kartik, can you hear me? Oh, okay. Yeah, just to kind of touch upon this particular question, right? I think the point being that first of all depends on what field of AI are you interested in. So you have tried out with OpenCV, I would say like a bit of the computer vision side of things, and then of course generative AI itself. You can dive deeper into the multimodal models, or you can focus primarily on just the text-based models as well. So ultimately, now having gone through the core AI basics and also the Gen AI, ultimately you have to find what that particular niche you want to work at, because that pie shaped learning, that having that horizontal understanding of all of the major concepts, and then diving deeper into the field that you feel passionate about. Because of course, whether you want to consider going into data science, or going in as an NLP engineer, or as a computer vision engineer, or even someone who's focusing on generative AI specifically, your core fundamental knowledge required in each and every aspect will be the same, right? So you need to have at least some basic knowledge of the maths, and basic how any machine learning algorithm works for that matter. So that would depend on what you want to accomplish. And when it comes to like, am I going too fast? Uh, that is something that you, of course, you will be the best judge of yourself. But just to ensure that as you skip or as you transition from one concept to another, that you have done enough practice. You understand that particular foundational algorithm well, you're able to implement that in let's say any language of your choice, and you have built enough projects, covered different kind of edge cases, tried it out with different kind of data sets. I think like that's the key. And when you feel comfortable, then you can always move to the next step. So I hope that that adds. But if anyone else wants to add more to this.
Yeah, maybe it's open to all. Maybe if Abheesth or Karan want to add something, they can. Yeah. Is there anything like maybe Karan or Abheesth want to add? Let me know. Otherwise, we can jump to the next question. If that. Good. Okay, I guess there is no more to add. Aditi Singh has asked, my question is to Abheesth sir, what's the use of user data in ML or AI? I guess Abheesth already answered that. But Abheesth, in a summary form, if you want to answer, if you want to answer in that way, can you? Yeah.
Yeah, I mean, pretty much the same. I mean, I'm just talking specifically about my area of research right now. But yeah, user data is useful for sure. And yeah, I mean, I think I've spelled it out like pretty clearly in the answer itself. So nothing more to add there. Um, yeah.
Sure. Next question is from Cyberpun, I guess. I am facing some complexity while quantizing the LLMs for training in Collab 2 days ago. I tried quantizing Pi 3 4 byte, basically to 8-bit, but got on out of memory error. Tried the same quantization and training params with some exact same dataset for Llama uh, okay, 27B, and to my surprise, it worked. Any idea what could be the reason for this? PS, I know it's difficult to say without looking at the code, but I appreciate any kind of help. Thanks. Who want to go with this? Anyone want to take this question? By any chance, is there anyone who giving answers, or is it my internet issue?
A quick question we hear, I guess, would
Yep.
be that is like what reference is the output of memory issue? Is it for example, if you're training it with an NVIDIA GPU, is it like more of a CUDA error? I'm just trying to understand that a bit further, because that can perhaps set more context.
Yeah, could out of error, memory error. Yeah, yeah.
Because sometimes like what will happen is that, okay, like if you are sending a very large prompt, I guess, but that would not necessarily apply to quantization, right? So yeah, I guess like if you can just provide a bit more information. because the only thing just want to understand is that this is more on, okay, like when you are actually doing the quantization, you're allocating the memory to GPU. So is this the GPU like a CUDA error out of memory, like the okay, CUDA out of memory error, T4 GPU. Okay, okay, this makes sense. Um, okay, this is a bit. So it could be, what I understand is sometimes, um, what what is a bit common error, that sometimes you actually get like a bug in how the GPU memory allocation actually takes place. And sometimes what might happen is that even after you have loaded a model, the entire GPU memory might not be allocated. Uh, so basically, like sometimes there's no more GPU memory left in the main GPU for the context to be fully allocated. And so I guess like just because I don't have access to your code, that is what I can think of. Um, and depending on the architecture of the model, it may work for certain models and it may not work for other models. So might have to just look into what are your training parameters and how you're actually leveraging it. So perhaps you might want to just share your, if you don't mind sharing it. But Abhishek, if you want to, if you want to add something to it, Abhish.
Abhist, if you want to add maybe from audio, maybe everyone can listen to that. Yeah.
Hello. Hello. Yeah, sorry, I was muted. Yeah, I was saying, yeah, so I'll have to go over the code and we can actually, like, you can contact me on LinkedIn and we can actually go over the code and try to figure it out.
Cool then. I guess I have one. You can obviously reach out to Abhist. Like we will share all the social links of speakers, so do not take tension around it. Otherwise, Abhist is on the Discord. You can reach out to them on from Discord or like anything like LinkedIn or Twitter, which is good for you. Okay, I guess there is no more question till now. Folks, if you have any other queries, drop down this section, and we are going on the final front of it. Uh, I guess Karan has to go because he got some work around it urgently, so he pinged me basically. But cool. So next part, what are the final tips? Can you go like Abhish and Shivay to the audience? How they basically utilize everything and start working like in terms of collaboration and everything and all that. So yeah, and final tips basically you can say. What are the final note you can give to the maybe students or participants, those who joined our Tensor talks? Yeah.
By the way, I think there is another question that is asked in the chat. Do you want to probably take that up before the final
Yeah. Oh,
thoughts?
so sorry. Yeah. Akhilesh, hello sir. My question is that whether we have to more focus on DSA or start building projects on AI ML journey. Shiva, if you want to take it up, or Avist, anyone can take it up. Yeah.
Yeah, see, I mean, like basic data structures are definitely important if you are planning to do a lot of programming, because of course, you will be using programming whenever you're building an AI project. So at least having a fundamental understanding of how lists work, how dictionaries work. I mean, of course, their direct application might not be as straightforward as building like a software project, but at least having basic level knowledge of how they work is always good to have, because sometimes even as an AI engineer, you might be required to work perhaps on the MLOps side. Now, if you understand how queues work, because a lot of times you get so many amount of requests, you have to push all of your requests into an incoming queue, right? If you're using a queue like structure with something like a Apache, Kafka with the producer, and so I mean, the point is that having basic level knowledge of DSA is always helpful. It's not going to make your journey into DSML bad, right? It will only make it better. But that being said, that you don't have to be an expert necessarily, right? You don't have to be like doing competitive programming to become better at data structure algorithms or at DSML. You can still build projects with basic level knowledge of DSL.
Abhish, if you want to add something to that.
Yeah, I mean, yeah, pretty much the same. So I actually never did DSA properly. I mean, like basic DSA, everyone does because it's part of your curriculum, etc. So you can learn the very basics, as Shivai said. Uh, but yeah, the issue is that companies, like even for AI/ML roles, they have DSA interviews. So they'll probably have say one DSA interview and then three, four ML interviews. And so DSA is just a way to check your basic programming skills, at least for you know ML jobs. SD jobs, of course, you need to uh, you know work harder on DSA. Um, but yeah, so so basically, what you should do is if you're getting into ML, focus more on ML uh, and keep doing a bit of DSA or lead code on the side. Uh, and that should be good enough for ML jobs, at least.
Thanks, Abhish. Just wanted to add this thing. DSA, like obviously DSA is really important, but I will say you should have a good grasp of object-oriented programming. Basically, like that's I can bet on that. It's really important because while I'm going through the like when we say abstraction of polymorphism, right? That kind of concept really required when you're building any model from scratch, like with using class object concept basically. Even the functional program is good, but still always prefer or object oriented programming in that way, so you can work on that. And last question to Abhist, I guess, can you share your Amazon interview journey or like how it goes and all?
Yeah, for the applied scientist role, you'll have so it'll start off with a phone screen round where they can. I mean, as I said before, that like when you're starting your ML journey, you should focus on breadth. So the phone screen round will just be a general test of your ML knowledge, and then if you clear that, you have a DSA round. So the next four rounds are basically conducted together, as in, so once you've cleared the phone screen round, it's not like if you tank the DSL round, they won't conduct the rest of the rounds. They will conduct the other rounds as well. So there's one DSA round, and then there are three machine learning rounds. There's ML breadth, there's ML depth, and there's ML application slash hiring manager round. And so yeah, I mean, ML breadth focuses on. I mean, I've talked about it before, but focuses on breadth, where they'll probably, want you to have a basic knowledge of, uh, machine learning, probability statistics, linear algebra, and so on. But again, depends on the team. It's very team specific. Uh, so, for example, a team like Alexa will ask you NLP questions, obviously. Um, and my team, for example, uh, which has tabular data, it will focus on say XGBoost and uh, you know uh, multilayer perceptron, but it will also it can also ask you NLP questions because we devise NLP solutions for non-NLP problems, basically. Because it's user activity uh, data, right? You have a sequence of clicks which are ordered by time. So yeah, so these are so ML breadth, ML depth. ML depth is where they'll ask you which topics you're comfortable in, and say you say something like transformers, then they'll ask you, explain what attention is, write down the equation of so and so, or uh, you know, tell me what positional embeddings are, stuff like that. So it's ML depth, but still it's pretty general, I'd say. If you've done prior research, they might even ask you to explain your research to them or defend your research to them. Um, that's the ML depth round, and then you have the hiring manager round, where the manager will try to figure out whether you're suited to the team, uh, whether your interests align with what they're doing, and so on. So these are the four rounds which happen post the phone screen round. And once you clear that, there's this bar raiser round where they'll over the course of the previous four rounds they would have figured out what your weaknesses are. My weakness was DSA, so they spammed me with DSA. But yeah, if you've say not done so well in the ML breadth round, then they'll focus on ML questions. So yeah, that's how it goes. And yep.
Thanks, Abheesth, for
Yeah.
sharing a journey around it. Any last tip to the audience, and we will end this end our today's Tensor Talks. Yeah, end of this week. Maybe Shivay, can you go first? Yeah.
Yeah. I think in terms of tips, as the speakers have already mentioned, some really valuable points. I think the major aspect is don't be scared of failure. It can be fairly tricky to get the right kind of algorithm and get good accuracy when you are building these projects, right? It's all about taking it slowly. Because I would say that as you go deeper, what you'll soon realize is that the actual algorithm itself, a lot of times you're just using a run of the mill algorithm, and the code for that algorithm is already there. Like it's usually just 4 to 5 lines of code. Where most amount of your time is going to go is getting the right kind of data and understanding how can you better clean this data, right? So a lot of your time will actually go into those that aspect of ensuring that the data is of the highest quality, whether it's duplicate data or you have any sort of like null values, removing all of those, and also equally understanding that not every part of your data set is actually required. Sometimes you might need to do normalization of your data to ensure that your data is not, like some values might be ranging in between 0 to 0.0001, whereas some values might be 1000, 2000. I mean, depending on what kind of data set you're collecting. So all of those things, in order to ensure that your data that you're now going to be using for training is in pristine quality, is what actually takes up most amount of your time. And then, of course, tweaking the weights. If you're like talking about the neural network, tweaking the weights and the bias values, right? Um, doing the back propagation to see how you can improve if the model is not performing well. So this understanding this part, that the actual time that it takes for writing the model script is perhaps the least amount, but it's more of that data exploration and data prep that will take most of your time, and that can be a time consuming thing. So that's why also equally important is to understand all these different techniques, gradient descent, all those optimization techniques. Those are what come in handy when it comes to improving the quality of your model. A lot of times we just focus on the core models themselves, but then there are all these different concepts within machine learning. When you will perhaps take up a course or you go through documentation, that you should learn about them equally as well. So yeah, I mean that's just a couple of cents on how would your journey look like when you kick off into here.
Thanks, Shivay. That's great tips. Abheesth, any final pointers from your side to all the attendees? Yeah.
Yeah. I actually forgot to mention the role of open source here. And so if you guys want to learn, and if you want a community to learn with, open source is the best way to go about that. So you, uh, I mean, there are obviously open source programs like GSOC, etc., or Outreachy and so on. But you don't always need to do that. If you just want a learning experience, you can just find a library or a repo on GitHub you love, you would love contributing to, and you know uh, develop a rapport with the maintainers, and because they are way more experienced than you are, and this is something I would suggest at any stage in your undergrad or even after that, because you'll be rubbing shoulders with more experienced folks, uh, and this is especially relevant for, by the way, first or second year, when you don't have an internship and you desperately want to learn more. And so you reach out to maintainers, uh, you contribute to repos. As I said, code is the source of truth. And yeah, so I learned a lot by just contributing to open source, because you learn from other people, and people who are more experienced than you are in the same field. So yeah, go ahead and contribute to open source. That's my final thought.
That's I can vouch for that also, because I get my mentor Shivay from even before that also, but like we worked more like during that period of time. I get into open source, and I guess we we three of us can vouch for that. Open source is the best way you can is the best way to basically to get industrial experience. From my perspective, computer science. If you are a computer science grad, this is the best branch you can ever have, because you just need a laptop and an internet, and you can work with the like in open source. Like you can work in open source with the industrial experts who are far more like lot of experience with you, maybe 20 years of experience, and you can still working with them just to show to passion about like you wanted to contribute to this project, you really want to learn from them, and this is the best way you can do it. And thank you so much to today's speakers, Abheesth, Shivay, and Karan also. Even Karan is not there due to some work, but thanks for that. And simultaneously, we are already doing our study jam. And I guess tomorrow Shivay will demonstrate a demo on KNN algorithm. Basically, it's a pure demonstration because I guess theory is already done. I'm hoping so from Tisha, I guess. But Shivay will take care of that in case you are didn't joining in that way. Uh, all things are recorded on our YouTube, okay, with the mathematics, stats, probability part, Bayes theorem, linear regression, everything is done on our basically YouTube. So if you never able to get a chance to join those session, all things are all things are live on YouTube. It's all things are recorded. What I will do, I will create a playlist for you where you can directly go through and go one by one to basically understand the whole concept. Okay. We have also a GitHub where we upload all the resources of each day. And what we are trying to do, this is we wanted to ask from you, if I and Shiva start something with the assignment kind of thing for you all, will you do it with very passionately, like the assignment thing of ML, because we have to put our time to that. So is it okay for you if we can build some assignments to you or not? Just let us know. And if it not, it's okay. And if you want to just go through the live stream also, that is also perfectly fine. Let us know on the chat section. It will be better for us to understand. Yeah. Okay. Abhi is saying it's 100. Okay. Others, let us know. But then only, but if you will do it, like that's the thing, because we are adding so much time to that. That's why we are saying. Okay. Cool. Uh, cool. And also we will, what I will do on the README part of Study Jam repository, I will add all the links of each day of YouTube links. So it will easy for you to basically understand what we are doing and all that. And please join our communal. That's a platform that all the RSFP thing has done, and share it with your among folks. Even though we are situated in Durg, but or like Chhattisgarh to be very precise, but we try to make it try to make our community very globalized to that. and maybe on August September we will try to do something in person, a kind of big event, a really big event. So stay tuned for that. And till now, thanks for joining. Again, thank you so much, speakers Abheesth, Shivay, and Karan, for joining and sharing your thoughts. And we'll definitely meet you in person like soon. So yeah, thanks for joining. Yeah,
Thank you for inviting Kartikey, and thank you for listening.
thanks. Yeah,
Thank you. Yeah. Bye bye.
cool, folks. See
Bye
you,
bye.
folks. Bye bye. Take care. Yeah.